As the automobile industry continues to shift and concentrate on an all-electric future, many firms are abandoning combustion engines. However, Toyota has made its stance clear. It does not subscribe to the idea of an exclusively electric future. The Japanese car maker is looking at other energy sources while also preparing to launch some impressive electric automobiles next year. While the rest of the world was largely concerned with electric power, Toyota was carefully working on something different. The GAC Group, a Chinese state-owned business in which Toyota Motor Corporation has a 50% interest, has developed the first ammonia-powered engine intended for passenger cars. This caught the community of EV makers off guard and poses a serious threat to the trend toward electric vehicles. In the field of automobile technology, it represents a breakthrough never before witnessed. In this video, we will look at the groundbreaking innovation from Toyota. Before going into Toyota's powerhouse engine, it's essential to understand the concept of an ammonia engine and its significance. An ammonia engine is fundamentally a type of internal combustion engine that uses ammonia as its primary fuel source. Ammonia differs from the normal oil or gas-based fuels. It does not contain carbon atoms. This means that it does not release carbon dioxide during burning. This positions ammonia engines as a potential future pollution reduction strategy. Several approaches can be used to make ammonia engines operate effectively. One approach is dissolving ammonia into its hydrogen and nitrogen components. Blending ammonia with other fuels such as diesel, gas, or hydrogen is an alternate strategy that makes prolonged combustion and simpler ignition possible. This technique was used by MAN Energy Solutions to create a two-stroke green ammonia engine specifically for marine applications. The third approach involves using ammonia as the main fuel. This method needs the use of cutting-edge technologies like spark ignition, compression ignition, or homogeneous charge compression ignition. The future offers great promise for ammonia engines. The high energy density of ammonia is one of these engines' main benefits. The high energy density of ammonia describes the significant energy that may be held inside a certain volume of ammonia. Ammonia engines are especially well suited for applications where high energy density is of utmost significance because of this characteristic, which is essential for effective energy storage and delivery. This specifically covers the transportation and power generating industries, where efficient energy storage and usage are essential elements. The broad availability of ammonia is another benefit. Several elements, particularly the abundantly present nitrogen and hydrogen in the Earth's atmosphere, may be used to produce it. This accessibility emphasizes how feasible ammonia engines are as a source of renewable energy. Toyota has made a huge leap by collaborating with Chinese automaker GAC to create a brand new engine. This partnership birthed a 2-liter ammonia-powered engine. Toyota gave the impression of taking a more cautious approach to the electric car trend for a number of years. Toyota was discreetly conducting trials, first with hybrid vehicles and then with hydrogen fuel, while other manufacturers were rushing to electrify their cars. This engine, which was shown at GAC's yearly technological exhibition, has a 161 horsepower output. However, its tremendous environmental effect is what really sets it apart. Incredibly, this engine produces 90% less carbon dioxide than its petrol-powered competitors. This engine represents a significant step forward at a time when cutting carbon emissions is not only a goal, but a dire need. The development process was not without its difficulties, though, and that must be acknowledged. According to reports from Autocar, the development team struggled to manage increased combustion pressure and address excessive nitrogen emissions, among other problems. These significant obstacles serve as a reminder of the commitment and creativity used to develop this ammonia-powered engine. Overcoming the inherent difficulties posed by efficiently and quickly igniting ammonia is one of the endeavor's most notable successes. Ammonia has historically been harder to ignite than traditional fossil fuels, which has prevented it from being widely used as an alternative energy source for a long time. But the company's engineers overcame this difficulty, opening the door for ammonia to be successfully used in the passenger car sector. Chi-Hong Zhang, an engineer at the GAC R&D Center, remarked, "We've overcome the challenge of igniting ammonia quickly and have made it a viable fuel source for the passenger car industry." He also emphasized its societal and commercial value is highly anticipated. Various fields are becoming more interested in ammonia as a low-carbon fuel, but it's important to understand that in order to realize its full potential, a number of issues must be resolved. In contrast to traditional fossil fuels, ammonia is notable for having trouble igniting. The difficulty of effectively using it as an alternative fuel source is increased by the fact that its combustion process is also somewhat slower. Given these difficulties, broad adoption by automakers may call for more research and development, and quick deployment may not be forthcoming. However, the possibility of ammonia-powered clean-burning combustion engines is a promising approach for the automobile sector. Ammonia has its problems, just like any other fuel. It's a toxic substance, and a significant fraction of the world's supply is utilized mostly in agriculture, notably as fertilizer. Ammonia is also a component of certain medications and cleaning supplies. Ammonia manufacturing used to be an energy-intensive process. However, recent developments have seen the advent of green ammonia, which is generated using renewable energy sources and is a more sustainable choice. Ammonia's combustion properties make it difficult to use as a fuel technically. Compared to conventional fossil fuels, ammonia is harder to ignite and burns more slowly. This trait has somewhat hampered the adoption of this feature. However, as GAC's Chong Zhang pointed out, they've effectively overcome this obstacle, opening the door for its application in passenger cars. It's important to note that Toyota still has a sizable ownership position in GAC. Toyota's strategy for attaining emissions-free transportation is diverse and includes a combination of conventional electric cars and alternative fuels. Toyota actively investigates the idea of hydrogen-powered combustion engines in addition to its hydrogen fuel cell cars like the Mirai, as seen by its participation in a number of racing projects targeted at testing and assessing this technology. Given Toyota's innovative mindset and its investment in GAC, it's conceivable that the corporation may consider using ammonia-fueled power plants, starting in areas like China and maybe moving to other regions as the technology develops. It's important to remember that the agriculture sector uses fertilizer from around 80% of the present ammonia output. Ammonia is also used in different sectors, including those that produce explosives, dyes, plastics, and different chemicals, demonstrating its availability and promise as a substitute fuel source. Even if the challenges persist, current advancements in ammonia engine technology are encouraging. Although China has the biggest electric vehicle EV market in the world, traditional combustion engine automobiles are still in high demand. The Chinese government may be considering a ban on the sale of vehicles using internal combustion engines, however, in a move reminiscent of California's regulations, according to signs. The development of alternative fuels, including synthetic fuels, hydrogen, and ammonia, may be able to increase the lifetime of combustion engines. A wider spectrum of customers will have a compelling and environmentally responsible option thanks to these cutting-edge fuel choices, which may someday be more affordable to manufacture than completely electric cars. They will also solve convenience issues while providing a compelling and environmentally friendly alternative. Toyota has a dominant presence in the Chinese market. It has even created EVs that are specially designed for this country. The strategic course taken by Toyota shows a dedication to accommodating a range of customer demands. It will be interesting to watch whether this technology advances to commercial availability and, if so, if it will be implemented on a worldwide level. The potential incorporation of alternative fuel-powered cars, such as those using ammonia, adds an interesting dimension to the continuous shift towards more environmentally friendly transportation alternatives, particularly in the context of China's changing automotive scene. Furthermore, it is vital to acknowledge that, despite the importance of GAC and Toyota's ammonia engine innovations, this technology has been developed before. The Korean Institute for Energy Research made some noteworthy advancements around 10 years ago when they developed a vehicle called the AMVE. An astounding 70% decrease in carbon emissions was achieved by this innovative vehicle's utilization of a mixture of 70% ammonia and 30% gasoline. The goal of the AMVE project was to investigate the feasibility of a totally ammonia-fueled engine and demonstrate the practicality of this technology. Although numerous initiatives have taken different approaches to ammonia-fueled engines, they all highlight the continuing attempts to fully realize the promise of ammonia as a cleaner and more sustainable fuel source for combustion engines. Further inventions and improvements are probably going to help achieve the objective of environmentally friendly transportation as this field develops further. What are your thoughts on this engine? Let us know in the comments section below.